Hello Science Lines, hello, my name is Lara. I am actually trained to teach physics up to A-level at a secondary school, but now I just stream free IGCSE physics and all ages lessons and Lego story shows into the internet for money. We've just finished our lesson on dogs versus frogs, a Lego story show on dogs versus frogs. And I thought, I'm just going to keep my frog costume on. I actually think it looks awesome and I'm bringing it in, it's a thing now. Right, while I chat briefly about the whole IGCSE physics thing, because this might be your first lesson, this is a very good time to join in. You can get started with the craft, please. Have you brought an A4 piece of paper? It can be scrap. This is scrap paper, but it's from my latest supporter magazine, which isn't with my supporters yet, so I don't want to show you what's on the other side because it's a spoiler. But can you get a piece of A4 paper? It doesn't matter if it's scrap or not. And can you fold it up, not once, not twice, but 3 times lengthways, okay? What I need you to basically have is 8 paper strips all the same size. So if you fold a piece of paper in lengthways in again and again and then you open it out again, look, you end up with 8 paper strips all the same size. Can you cut those up, please? And I will do the same thing. You need to, yeah, it'd be good if you cut all of them. You don't have to, but I've got some other stuff that we can do while you're doing this craft, and then we'll do the activity all together. So obviously some people already know this, and some people don't. If you're thinking of doing IGCSE physics, like the big cool physics exam that shows everyone that you studied physics, then there's 2 different exam boards that could write your exams, 2 different companies that could write your exam. And one of them's called Cambridge, and one of them's called EdXL or Pearson. And luckily for us, they both need you to know pretty much exactly the same thing. Pretty much. There's a few subtle little differences. People keep asking me which one's the best. I really, honestly, don't have any opinions at all. If you home educate, what you'll just have to do is look at where near you can do IGCSE physics, and they'll probably only have 1 exam board available. So then you just go with whatever they're doing. But you have to know before you take the exam, because there will be little bits that like Pearson want you to know that Cambridge don't want you to know. So when you're revising, you really need to know which one you're doing. But for now with me, I'm just going to cover it all, because almost all of it is relevant to you, whatever you're studying. And if it's not relevant, it's still interesting. Okay? So what we're going to do, because we're talking about waves, is we need to make every physics teacher's best tool for talking about waves. We need to make a slinky. We need to make a slinky because you might not have one and mine got broken by a child. So to make a slinky, you need to get 2 strips of paper and stick them together so that they are, do you know what the P word is for when lines are at right angles with each other like that? It's going to come up. I'm going to seamlessly link it later on in the lesson. It's called perpendicular. Yeah? You need your bits of paper to be at right angles to each other, perpendicular, and you need to sellotape them into place. And then I'm going to tell you a little story while you do some, I don't know, what would you call it? Weaving, I suppose. So sellotape those strips of paper together. It doesn't matter if you haven't finished, just do a couple. Look at the screen now anyway, even if you're still cutting. You need to get your piece of paper like that, perpendicular to each other, at right angles, like a L shape, and then fold one piece over like that, and then fold the other piece on top, and then fold the other piece over like that, and then fold the other piece on top. I mean, a lot of you will have done this before. I'm so excited if this is your first time ever folding a piece of paper like this. It's such a satisfying thing to do. And just keep going until you've done the whole thing. And what you should end up with is something that looks a little bit like a spring. And basically, the more of those you can put together before we do the activity, the better. It's good, isn't it? It's nice. So just get 2 pieces of paper, put them perpendicular to each other, not parallel like train tracks, at right angles to each other like that, and then fold one over, and then fold the other one over, and then fold the other. Very good, children. And fold the other one. I'm famously bad at crafting. Everyone always accuses me of going too fast or too slow. No one is ever happy when I craft. So what I'm going to do is I'm going to leave you to craft while I tell you a story. If you're new, the Theatre of Science has a mascot, an animal mascot. Can you tell what it is? It's a worm. So I've written a story about Wormy, the Theatre of Science mascot, in a situation which involves a lot of waves. And I'd like you to listen to the story while you craft and try and write down or just note how many different waves you see in the story. And what I'm hoping is that you won't see them all, or some of them you might think are waves and they're not. And then by the end of this module, you'll be like, oh yeah, see what she did there. It's a good one, Lara. Okay, I've joined, I think, enough of these together. I think if you do all of them, your slinky will be long enough for our purposes. You could do it with a really short one. It's just the longer it is, the better it'll look. There you go. So I'm doing something like that. Okay, I promised you a story. Let's go. Let's go. Fit of Science presents Wormy in Trouble at Sea. Lots of different waves appear in the story. Make a note of those you see or hear mentioned. At the end of the module, you'll hopefully get all of them and spot any fakes. So here's Wormy living on her boat. I love living on a boat, says Wormy. Nice calm sea today, just ripples. I'll just microwave some soup. And then this is how radios work in emergency situations. The radio comes on. Breaking news. An earthquake has just happened. Oh no, says Wormy with a mouth wide open. So she slams on the TV remote control, and the TV remote control starts working. And the TV comes on. Here's a newsreader saying, luckily only one person was injured. They are in hospital, having x-rays. Behold, the picture of the x-ray. Unfortunately, the earthquake triggered an enormous ocean wave. By the way, could only find pictures where the newsreader was smiling. So it's just an irrelevant subplot that the newsreader is evil. I must get to the steering wheel of the boat. Straight away, says Wormy. I wrote this story 2 years ago for the first time I taught this module, and I didn't bother to look up what a steering wheel on a boat was called, and I still haven't. So sorry, not sorry. I don't know. But anyway, she heads to steer the ship in the right direction, but gasp! Oh no! She forgot she owns a massive treadmill. Oh, Wormy, whose body is now unusually long, falls onto the treadmill and makes the shape of a wave. But is that actually a wave, children? Is it? Is that a wave? She's not going anywhere, but she's moving in a... Is it a wave? We'll find out. Anyway, eventually she sees a lifeboat and says, hooray, the lifeboat is here. Better wave and let them know I need help. Then she remembers she doesn't have any arms. What are you going to do with me? She just kind of sways from side to side like that. Jiggy, 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 jiggy. And the lifeboat says, help is on the waves. The end. Wormy construction, Olivia P. Right, you lot, have you made your slinky? Is your slinky constructed? We need to use our slinkies to talk about something that waves definitely do. All of the waves do this. And something that waves definitely do not do. No waves do this. So what you need to do is, please, whatever stage your slinky's at, it doesn't matter. It would be good if you could sellotape it to a table, or, I mean, if it's really long, put a cushion or some kind of weight on top of it, put a can of beans on top of it to stop it moving around. But it would be good if one end of your slinky was fixed in place. I'm going to get some extra sellotape because it twanged off. It's a proper physics teaching term. It twanged off yesterday during the lesson. It's all very awkward and embarrassing and not professional at all, she says, wearing a frog costume. Here we go. So, make a wave with your slinky, please. Can you tell me any ideas? What do waves carry and what do they not carry? And the negative is as important as the positive in this. So I've got a nice long slinky. You might not have it this long, but I'm just going to move my hand from side to side and make a wave. Oh, do you know, I love all physics, but we've been learning about electricity, and it's so annoying because you're just constantly learning about models. This is so nice because this isn't a model of a wave. This is actually a wave. It's not me just showing you how waves work. It is actually how waves work. So I think stretching it out might be better. So I'm making a wave. What is my wave carrying and what is my wave definitely not carrying? What is my wave carrying? What is my wave not carrying? Some of you will obviously know this already. Some of you will have read ahead. If I put this little Lego person here, this is supposed to be Ferrero Rocher for a Lego story show that I did. What is getting to that Lego person and what is not getting to the Lego person? Shall I just keep doing this at you? Does this help? Well, your GCSE specification tells you, both of them tell you, both of them want you to know this. You have to know that waves transfer energy without transferring matter. So energy is getting carried by the wave, and you can tell that, right? If this was slightly positioned differently, we could whip the Ferrero Rocher out of that little Lego person's hand using energy from our hand. It's good, isn't it? We put energy in at this end, and the wave carries the energy to the other end. But what is not moving is matter, which is the posh physics word for stuff, right? Paper particles over here are not travelling along the wave to the person. Now, I think, especially when you think of ocean waves, it's probably the most famous kind of wave. This is really surprising. All waves carry energy, and they don't carry matter. Matter is just the posh physics word for stuff. Because if you, like, if I'm at the beach and I look down at the ocean, I'm sort of imagining that those water particles that are lapping against my feet have journeyed from, hundreds of miles across the other side of the ocean, and that the waves have brought those water particles to me. But that is not actually what is happening. I mean, water particles obviously are moving all the time, because water's not a solid, so they are moving around, but the waves aren't carrying the water particles in that way. And you realise this if you look at a ship in the ocean, if you look at a boat in a storm. If you've seen it in a film even, the ship doesn't race along the surface of the ocean, does it, in the direction of the waves? That's not what happens. It goes up and it gets slammed down again. So the ship is moving up and down, even though the waves are carrying energy perpendicular to that motion. Is that okay? So in this picture, the ship is moving up and down, for example, and the waves are moving to the side, perpendicular. When you clap your hands, this is a true fact. Come on, let's make it an interactive lesson. Clap your hands. So when you clap your hands, air particles next to your hands vibrate. So let's just look at one air particle. You clap your hands, you make an air particle next to your hand vibrate. True story, you hear a sound. So where has the air particle moved to, please? Has the air particle that is vibrating because of your hand movement, has it moved away from you? Has it moved to just outside your ear? Has it moved to inside your ear? Or could it have gone anywhere? When you clap your hands, I'm doing it, I'm looking at my hands as if that will help. You move air particles next to your hands. Does that air particle move away from you, to just outside your ear, to inside your ear, or could it have gone anywhere? Keep your slinky, by the way, you're going to need that again. Well, the answer is that it could have gone anywhere. Actually, I don't want to do too many spoilers because we'll do a whole lesson on sound. But how sound works is it's just air particles boshing into each other like dominoes, right? So that single air particle vibrates to and fro and bashes into another air particle, which vibrates to and fro and bashes into another, which eventually gets to your eardrum and your brain hears it as sound. But that single air particle hasn't carried the sound to your ear. Okay then. Which direction, again, not trick questions, I often do ask them, but I'm not asking them this time. Here's the wave that we just made. Which direction is the energy travelling in? I mean, I've basically already said this. Which direction is the energy travelling in, and which way is your hand vibrating? The sort of posher word for vibrating, stuff moving to and fro, is oscillating, right? Should we try and get some art on the go? Here's your hand. With a thumb? I don't know. Here's your hand. Here's the Lego person. Which direction is the energy moving in? Well, hopefully you're saying from the hand to the person, side to side, basically. And which direction is your hand oscillating in? Along which plane is your hand oscillating in? It's going up and down, okay? So this is a special kind of wave. There's only two kinds. And this is the first kind that we need to talk about. Oh, look, I wrote it on the board. Which direction is the energy travelling in? Which way is your hand oscillating? And oscillating means moving to and fro. So this special kind of wave, ocean waves is this kind of wave, is called a transverse wave. A transverse wave is a wave where the vibrations, like in this case up and downy, are perpendicular to the direction of energy transfer. So the energy is transferred in one direction and the vibrations are transferred or are in the direction of perpendicular to that. Is that okay? So that's a transverse wave, right? Good. So an ocean, the slinky wave that we just made was a transverse wave, because that was the case, and ocean waves are transverse waves as well. So, but can you, I mean, maybe you've already done it. Maybe when I said make a wave with your slinky, this is the first thing you thought of. Can you make another kind of wave with your slinky? Can you make a type of wave with your slinky where this is not the case? The direction of oscillations and the direction of energy transfer are not perpendicular to each other. Well, I suppose that was it's kind of a clue. You can. What you need to do is ping it. There you go. Is that a wave? It's less like how we think of as a wave, isn't it? But what's happening here? We are transferring energy to this little Lego person, definitely. They'd be able to feel that, even though we're flicking all the way over here. And something is oscillating, isn't it? Something is vibrating to cause that wave. My finger is now oscillating to and fro in the same direction as the direction of energy transfer. Gasp, they're parallel with each other. But matter is still not being transferred, is it? Because that's not what waves do. We still haven't got any paper particles moving. So yeah, that is a wave. It's the second kind of wave. And it's called a longitudinal wave. And sound is a longitudinal wave, where the vibrations are travelling in the same direction as energy transfer. Be careful with saying things like up and down or side to side, because obviously waves can travel in all different directions. But the vibrations and the direction of energy transfer are, we would say, parallel to each other, right? Both moving along the same plane. Here is a brilliant photo that someone took and stuck on Wikimedia Commons, thank you, of a longitudinal wave travelling through a proper slinky. And in a longitudinal wave, you get these areas where the waves are very squished together, which are called areas of compression. And you get the opposite, where they're spread out, which is called areas of rarefaction. So here's a sort of classic diagram of a sound wave with the areas of rarefaction, the wave being spread out, and the areas of compression, the waves being close together. So it's sort of like a pulse. Here's, I think, a Japanese diagram helpfully showing what happens if you whack a solid thing with a hammer. You get these, well, pressure waves, I suppose, travelling through the solids. Can anyone think of what that's a good model for? Any geography fans in the proverbial house? If you like learning about earthquakes, you might have heard about the different kinds of waves that earthquakes produce. You get transverse waves, which are called S waves, which are the very shallow waves, do a lot of damage, just travel along the surface of Earth. And you get waves like the ones that we just saw, pressure waves, P waves, where you get these areas of rarefaction and compression. They're longitudinal waves, just go kind of through the Earth. Okay, yeah, do this sheet for me, please. I've already said too much. Just have a go at this sheet, because that's a huge amount of what we need to learn today, just on that one sheet. You've just got a little table here. Can you tick the correct boxes? You've got a transverse waves column and a longitudinal waves column, and I've said, do they transfer energy? Do they transfer matter? Which one is energy and vibrations are at right angles to each other? And which one is energy and vibrations are parallel to each other? Can you write down 2 examples of each? And if you found that very easy, can you tell me, are dominoes falling a wave? And can you explain your answer? I said that sound waves were a bit like dominoes, but if you lined up a load of dominoes and knocked the first one over, and they all fell over in a row, would that be a wave or not? I've just noticed I haven't got any comments on this video, have I? Sorry. I must have been in autopilot and turned them off. Usually, I don't have any comments on YouTube, but in any of my lessons, but I make an exception for the IGCSE ones, because you're just a bit older, aren't you? Probably. And a little bit more focused, because some of you actually want to pass IGCSE physics exams, so are less likely to start chatting about Minecraft and what your cat's doing at the moment. No offence to those other guys. But I've forgotten to put them on today. So if you go over to my Facebook page, if you would like to comment at me or ask me a question or just have me say your name for lolsies, if you go to my Facebook page, then the top post on my Facebook page at the moment, if you're watching live, says, please comment on this post and I'll read it at the end. So that is what I will do. I think Arthur's here. I wonder if Fred's here. Fred's new, and Fred came to 2 of my lessons today. Who else will be here? Bastian will be here. Oh, I know Skylar's here. Bella will be here, right? Izzy B is here, maybe? Anyway, have you done that? Shall I stop talking so that you can focus? Now I'm very worried about all the people whose names I haven't said. They might be really angry with me. That Grace might be here. Jacob will be here. I'm just going to stop saying names. If I haven't said your name, I still love you very dearly and you're very important to me. I'm going to stop saying them because I'm just going to get myself into a world of trouble. If I hadn't said your name, you can shout at me about it on my Facebook page and I'll read it at the end. Should we go through it? I'm sorry, I just talked at you that whole time while you were trying to think. All right, I'm going to go through it. Do they transfer energy? Yes, both of them transfer energy. That is what waves do. That is literally what a wave is. Do they transfer matter? No, they do not. Waves do not do that. The ones, I gave you a picture, so it was good clues. Energy and vibrations are at right angles to each other. That's the transverse wave, okay? You move your hand up and down, and the energy gets transferred from side to side. And the energy and vibrations be parallel to each other. That's the longitudinal wave. Your finger goes from side to side and moves energy from side to side. 2 examples of each. Well, I put ocean wave for transverse wave and slinky. And for longitudinal wave, I put sound waves and slinky. Can you tell me my deliberate mistake? What mistake have I made there? Why am I right? Why am I wrong? I'm right and wrong. I'm right, but I wouldn't get any marks at IGCSE. Well, I'd get 2, but I wouldn't get 4. Write down 2 transverse waves and 2 longitudinal waves, and I've written ocean wave and slinky are transverse and sound waves and slinky are longitudinal. Why am I only getting 2 marks at IGCSE? I've got to be more precise, haven't I? You've got to tell the examiner what you mean. You might be cheating. It would be okay to say that an example of a transverse wave is a slinky where the vibrations were at right angles to the direction of energy transfer. Or a longitudinal wave is an example of that, is a slinky where the oscillations are parallel to the direction of energy transfer. But you've got to be a bit more specific. You can't just say slinky, or you could be cheating. Are dominoes falling a wave? What do you reckon? The internet is a bit divided on this, to be honest. There's no precise answer, but well done if you thought about it and got some brain exercise. Generally speaking, yeah, they are thought of as a wave, because well done if you thought, well, they transfer energy. The last domino gets knocked over because the first one gets knocked over, but they don't transfer matter because none of the dominoes move to the end. But it is a bit hazy because there aren't any vibrations, are there? You might have picked up on the fact that waves are caused by oscillations, vibrations, things moving to and fro, and that isn't what dominoes do. Is a wave a wave? Hello? Is that a wave? No, it's not. It's moving to and fro, so it is an oscillating thing, so it could make waves, but it's not really a wave on its own. I mean, it does, if you put your face in the wave, that's weirdly painful, then waves do transfer energy, you can feel it, but they also transfer matter, don't they? It's just not a wave. Right, last thing before if you've been to my Facebook page, if you've been to my website, you've got the free printout of this lesson. It doesn't matter if you haven't, but if you have, or you can go there after this. There's a load of past paper questions at the end that I've written for you. We're not going to do those today because it just ended up being too much yesterday. I want you to do those for homework, and then we'll go through them at the start of the next lesson, which I don't normally do, but I think it'll be a good way of recapping the lesson next week. So what we'll do now is one quick little activity, and then I'm going to give you a little bit more information and then do a quiz, and then we'll finish. So if you've got a cup of water in front of you, Can you please make a transverse wave and a longitudinal wave using your cup of water? You can move the cup of water around, obviously keep it away from computers and stuff. But how? By just moving this mug of water around. Oh no, spoiler, look, I'm doing it. How would you produce both, not necessarily at the same time, but how would you produce a transverse wave and a longitudinal wave just using this cup of water and your hand? What are you going to do? Have you done it? Transverse ones, well, am I going too fast? I really want to give you time to think about this. Do you know what? I'm just going to count to 10 silently in my head so that I actually remain quiet so that you can have a think. Produce, you can do it separately, you don't have to do them both together. Make this water be, well, just make a wave that is a transverse wave and make a wave that is a longitudinal wave just using this cup of water. Longitudinal one is a bit tough, isn't it? You may be saying, okay, if I just wiggle it to and fro, that makes a transverse wave. Do you think it does? I think it does. So if I wiggle it to and fro, can you just about see? Oh yeah, look, if I wiggle it fast enough, I can actually get 2 peaks. I can just about see. It's quite hard to do while you're holding a camera. But that, I'm definitely making a wave that is going up and down, I think. So I'm shaking the mug from side to side. Oh, wait. Oh, no, I've just thought, actually. This is the first time I've ever thought, wait, what's going on there? Because I was going to say that's a transverse wave, because it looks like that. It looks like a wobbly wave. But actually, I'm moving the mug from side to side, aren't I? So now I'm thinking, what? Because the vibrations, the oscillations are going side to side. And the energy transfer is side to side. I've taught this lesson so many times and I'm suddenly second guessing myself and thinking, is that right? I don't know. I've really confused myself because I should be moving it up and down, shouldn't I? And the water be swishing up and down, but it's not. So does that make that a longitudinal wave? Well, I don't think so because I can literally see the picture of it being a transfer. Well, you can use your mouth anyway. If you blow in the middle, that's certainly a transverse wave. It's a good transverse wave, isn't it? So ripples on a pond would be a transverse wave. What I was thinking was, if you smack it up and down, gently, because it's my favourite mug, that must be a longitudinal wave being produced there. It's the power trying to go back on, that's what it is. Because the oscillations are up and down, and we can see the surface of the water moving. So what must be happening is that water particles, similar to dominoes or air particles in a sound wave, must be boshing into each other and travelling through the mug in the same direction as our vibrations, like that. You did it. There. I'm kind of alarmed here. Sorry, I'm just doing as many Jurassic Park quotes as I can. But yeah, I think. Well, let's move on. Right, quick FYI. At IGCSE level, we tend to say direction of propagation instead of direction the wave is going in. This is an important thing to remember because whenever we draw waves on a board, if I'm drawing a sound wave, I'm going to do something like that, which makes it look like when you make a sound, the sound conveniently just travels from the thing into your ear. Obviously that is not true. When you clap your hands, air particles in 3D space are getting vibrated and the sound is propagating, just spreading out into the room, right? It's just you hear it wherever your ear happens to be. Okay, let's move on. Last thing, we need to learn how to talk about waves because we're going to be talking about them a lot. So we need to learn how to label some of their bits. This is, I've made a little mistake here actually. I can't tell you that for sure that this is wavelength because I haven't labelled my x-axis. Can you pretend that this says like meters? And then this is the wavelength here. But the wavelength is basically the length of one complete wave cycle. It can be from anywhere to anywhere. So here the wavelength is measuring from the peak of one wave to the next peak, and that would be one wavelength. The way I like to think of it is, if you put your finger on a wave and keep going and going along the wave until you start repeating yourself, that's one wavelength. So if you start at the top here, you go all the way down past the midpoint, you go all the way up past the midpoint again, and when you get to that peak, you've started repeating what you've already done. So that's one wavelength. But it doesn't have to be from peak to peak. It could be from the midpoint all the way up, all the way down, all the way up again, then you start repeating yourself. So that's one wavelength. It could just be from any random old place on the wave to the next same random old place on the wave. What about this here? From the midpoint all the way up down to the midpoint again. Is that one wavelength? Is it? Is it? What is it? If it's not a wavelength, what is it? Wavelength? No, it's not a wavelength. It's, in fact, half a wavelength, you would say. 0.5 of a wavelength, because it's got to travel that amount again to be a full wave, okay? The other one I'll quickly teach you before I start quizzing you on it is amplitude. The amplitude is the maximum vibration. It's as far away as the wave gets from the midpoint, okay? It's as far as the wave gets from the midpoint. So I've labelled here between the midpoint and the very top of the wave, the peak of the wave. That's the amplitude. You'll quite often get questions on this because so many people get it wrong. So many people think the amplitude is from the top of one wave to the bottom. It's not. That's not amplitude, but that is from the midpoint to the bottom of the wave. That's fine as well, because that's still the maximum that it vibrates away from the midpoint. Okay, have you got all that? Shall I just immediately test you on it? Here we go. Is this amplitude, please? You got a wave, and we've got a lovely blue arrow labelled from the middle of the, well, the midpoint to the top of the wave. Is that amplitude? Yes, yes, it is. That is showing you the maximum amount of vibration that the wave makes away from the midpoint. Yes. Is this amplitude? We've labelled from the midpoint to the bottom of the wave. Is that amplitude? Is it? But is it though? Is it? Yes, it is. That's fine. It's still the most the wave gets away from the midpoint. Yes. Is this a wavelength? You'll have to excuse the arrow. I haven't been terribly precise with my arrows. If we measure from peak to peak here, is that the wavelength? Well, you go all the way down, past the midpoint, all the way up, past the midpoint again, you get to the top, and you've started repeating what you've already done. So yes, that is a wavelength. Is this a wavelength? Is this a wavelength? My battery's low, don't worry, we can make it, we'll be fine. Is this a wavelength? You're going from the midpoint, all the way up, all the way down, back to the midpoint again. Is that a wavelength? Yes, yes it is, that's fine too. Is this amplitude all the way from the top of the wave to the bottom of the wave? Is it? Is it? Is it though? Is it? Is it? No. It's not. Hopefully you said no. Is this amplitude from the midpoint to the very lowest point available of the wave? Is that amplitude? Yes. I hope I'm not going too fast. All right, I'll plug my computer in while you think about this one. Is that wavelength, please? Going from the midpoint, it goes all the way down, all the way up again, and then down to the midpoint again. Is that wavelength? Thinking about how hard my child would be freaking out if my battery was low. They wouldn't be able to focus on anything else. There we go. Yes, that is wavelength. That's totally fine. You start at the middle, you go all the way down, you go all the way up, you get to the middle, and then you're repeating yourself, aren't you? So that's the wavelength. Is this wavelength from the midpoint all the way down to the next time it crosses the midpoint? If not, what is it? Yeah, it's not the wavelength, is it? It's half a wavelength. All right, let's throw a few more words in so that I can test you on them again, and then we'll finish. I've already talked about this. The top of the wave is called the peak, like the peak of a mountain, or you could call it the crest as well, like the crest of a wave, okay? So hopefully that's already probably in your language knowledge. The crest or the peak of a wave is a bit at the top, and the trough is the very lowest point, like a water trough, yeah? What horses drink out of. That's not too bad, is it? Here we get a little bit more complicated, I suppose. Frequency means how many waves per second. So if you imagine you were standing in a place and you timed 1 second, how many waves would go past you in that 1 second is the frequency of the waves. So for example, and it's measured in hertz, capital H, little z. Hertz just means per second. So if you're looking at this graph for me here, can you tell me what the frequency of this wave is? If we've got, you go all the way up, all the way down to the midpoint again, and then all the way up, all the way down to the midpoint again, and then it says 1 second, and then that happens again, and you get 2 seconds. What's the frequency of that wave? How many waves per second? How many waves per second? The answer is 2. 2 hertz, 2 waves per second. There you go. So I've even drawn them for you. There's one, and there's the other one. Splendid. Got it? All right, let's chuck them into the mix. Is the frequency of this wave 1 wave per second? What do you reckon? Is the frequency of that wave 1 wave per second? Well, it goes all the way up from the midpoint, all the way down again, and up to the midpoint, and 1 second has gone by. So, yeah, it is 1 wave per second. That's right. Next one. Is the frequency of this wave 2 waves per second? Let's see. It goes all the way up from the midpoint, all the way back down again, crosses the midpoint again, all the way up again, all the way down again, gets the midpoint again, and 1 second has gone by. So I think that's 2 waves per second. Yeah, exactly. Is the frequency of this wave 2 meters? Is the frequency of that wave 2 meters? Well, hopefully, by the time you get to an exam, you'll be able to quite confidently say, no, that's not true, because meters is a measure of distance and frequency is a measure of how many waves per second. So it's like saying that you ran 10 seconds. It doesn't work, does it? The units have got to be correct as well as the number. So that's not right. Is the frequency of this wave 2 hertz? Is the frequency of that wave 2 waves per second? Yes, it is. Goes all the way up and all the way down. Is that the crest of a wave? That star at the very top of the wave there, is that the crest of a wave? Is that correct to call it that? Is that what you would say? Is it? Is that the crest of a wave? God, I'd love it if that got you a mark at IGCSE in a year or two's time. Yes, that is a crest of a wave. Is that the peak of a wave? A little star labelling the very bottom of the wave there. Is that the peak? No, it's not, is it? What's it called? Can you remember? It's the, well, what's this? The very bottom of the wave. Is that the trough? Is it? Is that the trough? Yes, it is. What about this one? Is this half a wavelength? Starts from the midpoint, goes all the way up, comes down again to the midpoint. Is that half a wavelength there? Yes, it is. Is that the peak? The star labelled the very top of the wave there. Is that the peak of a wave? Yes, it is, isn't it? I don't know why I'm saying it is, isn't it? I've literally just taught you that probably. Oh, is the frequency of this wave half a hertz? Is the frequency of this wave half a hertz? Half a wave per second, is that right? Well, the wave goes all the way up, comes back down to the midpoint, and 1 second has gone by. So that is half a wave in 1 second. So yeah, the frequency of that wave is half a wave per second. Okay, last thing then, before we go, tiny little bit of extra knowledge, and then you've got literally everything you need to chat about waves. The period is slightly different from the frequency. Frequency is how many waves per second. Period means how long it takes a wave to complete a full cycle. So if you imagine this time, with the frequency is how many waves per second. It's you standing with a little stopwatch, timing 1 second and seeing how many waves have gone by. With the period, it's you starting a stopwatch, waiting until 1 whole wave goes by and then stopping the stopwatch and seeing how much time is on the stop. Do you see what I mean? It's how long it takes 1 wave to travel. So it's measured in seconds because it's just how long it takes the wave to do a full cycle. So what's the period of this wave then? It goes all the way up to the top, all the way right down to the bottom, and then to the midpoint again in 2 seconds. What's the period of that wave? How long has it taken that wave to complete a full cycle? It's not a trick question. The answer is 2 seconds. Right. Come on then. This is the last thing I'm going to ask you to do. before I flip you around and say bye-bye and go over to do some hellos on my Facebook page, can you tell me the frequency and period of these waves? Can you tell me the frequency and the period of these waves? So you've got one wave that's going all the way up and all the way down in 1 second, and then all the way up and all the way down in 2 seconds. And you've got one wave that's going all the way up and all the way down and all the way up and all the way down in 1 second. What's the frequency of both of those? And what's the period of both of those? So a reminder that frequency is the amount of waves per second and period is how long a full wave takes. Should we go through it? So the frequency of this first wave, how many waves per second? Well, it goes all the way up and all the way down, all the way up again, and that's in 1 second. So that is one wave per second. So the frequency of that wave is 1 hertz. Well done if you put in the units. It doesn't make any sense to just write a number. How far did you walk yesterday? 5. That doesn't mean anything, does it? That's not what you would do. The unit is just as important as the number, so make sure that you put it in. The period of this wave, it's almost confusing, isn't it? Because it's so simple. How long did a full wave take? Well, it's the same, isn't it? In 1 second, one full wave went by in 1 second. So the period of that wave is also 1, but it's 1 second. And this next one, the frequency of this wave, how many waves per second? It goes all the way up and all the way down, and then all the way up and all the way down in 1 second. So that's 2 waves per second, so 2 hertz. I'm writing waves per second to help you understand what it actually means, but 2 hertz is the correct answer. That's what you'd write in an exam. And how long does a full wave take? Well, it goes all the way up and all the way down, so that's 1 wave, but less than a second has passed by. In fact, because there's 2 waves in 1 second, I can see that in half a second, 1 wave has gone by. So it's a period of half a second. Is that okay? Whew. Right. We will leave it there, chums. Like I say, I wrote you some past paper questions that I put right on the end of your printout. If you go to my website, even if you don't have a printer, you can still see the questions. If you go to my website and you go to the current IGCSE section and find the wave section, then it says click here for printouts, and you can just see them on the screen and answer them if you want to. I'll just flip you around. Oh, hello everybody. That was a long time looking at the screen, wasn't it? I mean, you're still looking at the screen, but the screen has my face on. You know what I mean. So yes, I never usually do this, but if you go to my current IGCSE section of my website and you find the printouts for waves, there's the very last slide has some past paper questions on that I wrote for you. If you obviously you don't have to, I'm not going to put you in detention or anything, but if you want to, you could fill those in now, or you could fill them in later on in the week to kind of refresh your brain. And then when we come back next week for our second waves lesson, where we get to learn about the electromagnetic spectrum, and I get to wear my rainbows jumper and we get to make rainbows and stuff, we'll go through the sheet then, and it'll be a nice way of remembering what we've done this lesson, even if you don't manage to do it. Okay, you lot, that's the end of the first lesson on waves. Oh, I love teaching waves. I'm going to go over to my Facebook page because, yes, like I say, usually I would have comments on YouTube, actually. It hasn't happened today because I must have accidentally turned them off. But whenever I'm live on YouTube, I always put up a post on Facebook saying, if you want to comment on the IGCSE lesson, then you can comment on this post. Oh, look, comments! Let's hope they're not just saying something's gone horribly wrong. Oh, here we go. Brilliant. It's Edmund. How could I forget that Edmund would be watching? Hello. Oh, and Andrew. Hello. Right. Edmund says, dominoes falling are a wave because they transfer energy and not matter. Brilliant. They must be longitudinal because the vibration, movement of the dominoes and energy transfer parallel. Beautiful. I didn't even say that, did I? Yeah. beautiful thinking. I should say, I'm really sorry to bore you. Oh, hello, Jacob. Hello, Andrew. Dominoes falling is a wave. Yes, excellent. Good. Some excellent thinking here. Splendid. Jacob says, worms versus birds for Lego Story Show. That's a very good one. Okay, I'll go over to my Facebook group now and see if anyone's left me any comments there. How this works is, because this is actually my job, which I know is really weird. Like, I don't do any private tuition. I'm trained to teach physics to A level, and I don't do any one-to-one. I don't even do any kind of like small group sessions. Entirely how I make money is by streaming lessons live into the internet, and then people just choose to pay me. It's so weird. I wouldn't have thought it was possible. So I just make everything free. All the lessons are free. All the printouts are free. The homework is free. It's all stored on my website for watching on catch up. I feel like the IGCSEs are getting particularly good value because I have trained to teach physics, which took a really long time and was really hard work and didn't cost an inconsiderable amount of money either, because I had to get a science degree. So if you want to pay me for all I experience and the effort of planning the lessons, you can! And that keeps the lessons going. How it works is, if you go to my About section on YouTube, you get to this website called Coffee, and you can send me £5 a month. And that keeps me going, teaching, well, just doing all of the things that I just said. So an IGCSE lesson every week, an all ages lesson every week, which you're very welcome to come to, and a Lego Story Show. We just did it about frogs. If you didn't catch that, that's why I'm dressed as a frog. Yeah. Oh, there you are. Good. Okay, you're back. Good. Maybe it didn't go dark for you. It just went dark for me. I sent you Theatre of Science magazine, which I'm so proud of. I send you some, what I usually call rainbow glasses, but they're actually diffraction glasses, and we will learn about diffraction in this waves module. So it's a really good time to sign up to get some diffraction glasses, because we're learning about rainbows next week. I'll send you an information sheet about how they work, which again is IGCSE physics, so that's useful. And I'll also send you Theatre of Science magazine. I write it, husband designs it. It is totally awesome. It takes me forever, and it's a really good time to sign up, because usually when you sign up to support me, I send you a past issue. Like, this is the mould issue that you get if you sign up with £5 a month. It's got beautiful comics, it's got a load of information about fungus. It tells you how penicillin was discovered. It's got Choose Your Own Adventure. It's got a home compostable plastic bag that comes with it so you can grow mould and identify mould. Have I got any comments on my Facebook group? Let's see. And if you sign up with £6 a month, I also send you the sleep issue, which comes with organic lavender and some material so you can sew a little sleep squish, and it's got another comic and a Choose Your Own Adventure and an origami koala and loads of science about sleep. So usually when you sign up, you would get all those lovely things like the glasses and the magazine, and then you'd have you would be on the list, and you would automatically get posted the next magazine when it comes out. But that could take ages. Ages! Because I'm writing a magazine, which is basically a book at this point. It gets bigger and bigger and bigger every time I do it. And yeah, it just takes me ages. It could take 5 months, it could take 7 months, it could take a year. This one's been like a year in the making. Wait, I'm just wondering if maybe I didn't post in my group. I thought I'd posted in my group. Maybe I accidentally posted on my page twice. I did. Okay, fine. I've just found the other comments. Sorry, guys. Took me a little while. Oh, it's Tiger and Birds! And Eli's here! Yes, come on! Eli, are you still here? I'm really sorry, it took me absolutely ages. I was supposed to put up a post in my group and on my page, and I just posted twice on my page. Sorry. Eli, so pleased to see you, mate, if you're here. If you're not here, I'm so delighted that Eli came to this lesson. They're not here anymore. That's so cool. Oh, Eli's been part of the Science Alliance for so long. And hello, Tiger and Bird, who I've also met in I've met all of you guys in real life. Where was I? I got distracted, didn't I? Oh yeah! The latest magazine came out of my brain and onto the page, and I think I perfected it to the point where there is not a single spelling mistake, and all the pictures are in the right place, and all the and everything's very clear and beautiful, and it's at the printers, and it's coming back from the printers any day. So if you sign up now, you get all the nice things that I've mentioned, and then the very next month you will get the latest magazine. It's just going to be there, like right away. It's going to give you a really false sense of how organised I am and how often Theatre of Science magazine comes out. Because usually you sign up and then you've got to wait, I don't know, a really long time. So it's an excellent time to sign up, is what I was trying to say. Go to my about section, sign up to support me. Thank you so much. I'm going to go, and I will see you next week for learning about the electromagnetic spectrum, rainbows and x-rays and all that stuff. Bye!